Hello students, let's go for next problem on the obtaining the Fourier series. Okay, here's the question. Obtain the Fourier series of the function f of x equals to mod x in minus pi less than or equals to x less than or equals to plus pi, and hence deduce that 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square plus so on, that is equals to 5 square by 8. It means here we have two part of the question. One is to find the Fourier series for the function mod x, and after obtaining the Fourier series, whatever we have obtained the Fourier series, that we need to deduce to this form. Okay, first let us find the Fourier series for the function f of x equals to mod x. Let us solve that one. Let us consider f of x. F of x is equals to mod x, and it is defined in the interval. Defined in the interval, you can see that is minus pi to pi. You can see minus pi less than or equals to x, less than or equals to pi means the interval is minus pi to pi. Okay. Here you can see f of x equals to mod x, and that you can write it as mod means what? It contains negative and positive values. Let me write that one. It is minus x or it is plus x. Mod x contains both values. Okay. Minus x means it is minus pi less than or equals to x less than 0, or plus x 0 less than x less than or equals to plus pi. Means in the interval minus pi to 0, the mod x function is minus x. In the interval 0 to pi, the function is plus x. By taking this one, let us find the Fourier series. Okay, before finding the Fourier series, we need to check the nature of the function. We shall check even or odd nature of f of x. Even or odd nature of f of x. That is f of x equals to, to check f even and odd nature, we are substituting x equals to minus x because interval is minus pi to pi. That is equals to mod of minus x, which is equals to mod x. That means here we have obtained the f of x. The whatever given function f of x is the same function here we have obtained. Therefore, f of x is even function, means have even nature. Is even function. Okay. Since the f of x is even function, the Fourier quotient becomes 0. Since the function is even, the Fourier quotient Bn becomes 0. Okay, next. Now it is a even function. We need to find a0, the value of b0 and en. Okay, let us find first en. Now a0 is equals to integration 0 to pi 2 by pi integration 0 to pi f of x into dx. A0 is equals to, this is the Euler's formula. Consider the Euler's formula. A0 is equals to 2 by pi into integration of 0 to pi f of x dx. Now you can see the interval is 0 to pi, or the limits is 0 to pi. In that one we need to integrate the given f of x within the limit 0 to pi. Okay. The interval is 0 to pi. Therefore, what will be the function here? You can see here two functions are there. One is minus x, another one is plus x. Minus x, it is defined in the interval minus pi to 0. Plus x defined in the interval 0 to pi. Therefore, we want the function. Okay, you need to choose any one out of these depending on the interval. Now our interval is 0 to pi. Therefore, function is x. 2 by pi integration 0 to pi x into dx. That is equals to 2 by pi. Now integrate x with respect to x, that is x square by 2, 0 to pi. Then now 2 by pi into bracket x square, substitute the upper limit pi, lower limit 0. That is pi square by 2, lower limit 0. Means x equals to 0 means 0 only. Which is equals to 2 by pi into bracket pi square by 2. 2 get cancelled, 1 pi get cancelled, left with pi. That is the value of E naught is equals to pi. The value of E naught is equals to pi. Now let us go for En. En is equals to 2 by pi integration 0 to pi f of x into cos nx into dx. That is equals to 2 by pi integration 0 to pi f of x is x into cos nx d. X into pi we have chosen x because the interval is 0 to pi, therefore we have chosen x as a function. Now this is equals to 2 by pi. Now we need to integrate x cos nx using the Bernoulli's rule. That is x into integration of cos nx into dx minus d by dx of x integration of cos nx dx and with respect to dx. There. Now the values are, the limits are 0 to pi. Integrate this one. This is by Bernoulli's rule. Integration by Bernoulli's rule. Now do the integration. 2 by pi into bracket x into integration of cos nx is sin nx by n minus derivative of x, differentiation of x is 1. Next integration of one time integration of cos nx, just now we have did, that is nothing but sin nx by n into dx between the limit 0 to pi. That is equals to 2 by pi x into sin nx by n minus integration of sin nx by n is here in the denominator n is there, that is 1 by n is a constant term. Integrating sin nx is minus cos nx by n between the limits 0 to pi. Now 2 by pi, separately I am applying the limit now, sin nx by n 0 to pi minus 1 by n into 1 by n, minus into minus plus 1 by n into 1 by n is 1 by n square cos nx 0 to pi. Since we know that sin of n pi is equals to 0, this is a standard result, we know that sin n pi is equals to 0. If you substitute x equals to pi here, if you substitute x equals to pi, we are getting 0, that is 2 by pi, pi into, substituting the limits here, so pi into sin n pi upon n minus x equals to 0 means the total term becomes 0 plus 1 by n square into bracket cos of n pi minus cos of n into 0, or we can write 0 directly. Since sin n pi is 0, therefore this term becomes 0. 2 by pi 2 by pi. We are left with only second term, that is 1 by n square cos n pi. We know that. What is that cos n pi? Cos n pi value is minus 1 raised to n. Cos n pi, that is equals to minus 1 raised to n. These are all standard results. Minus 1 raised to n plus cos n into 0, cos 0, and we know that cos 0 is equals to 1 minus 1. Or what I am taking minus common from this term, that is minus 2 by pi into n square. 2 into 1, 2, pi into n square, pi n square. And I have taken minus common from this term, that is 1 minus of minus 1 raised to n. This is nothing but n. n is equals to minus 2 upon pi n square into bracket 1 minus of minus 1 raised to n. This is n. Now we know, and we know that dn is equals to 0. Therefore, we need to find the Fourier series. Here, Fourier series for the period 2 pi is given by, for the period 2 pi is given by, that is f of x is equals to a naught by 2 plus summation n equals to 1 to infinity an cos nx plus summation n is equals to 1 to infinity bn sin nx. bn sin nx, this is the Fourier series for the period 2 pi. Now here we have obtained the value of a0, and since the given function is given, the value of bn is 0. Substituting those values in the Fourier series, here we will get that is equals to f of x, that is equals to a0. a0 is pi by 2 plus summation n is equals to 1 to infinity n just now we have obtained. What is that? Minus 2 pi into n square 1 minus of minus 1 raised to n cos nx, and this term becomes 0 because we know that bn is equals to 0. Therefore, this whole term becomes 0. Now, this is the required Fourier series, that is pi by 2. Now I am just taking minus 2 by pi outside, that is outside the summation, minus 2 by pi, summation n is equals to 1 to infinity 1 by n square 1 minus of minus 1 raised to n cos nx. This is the required Fourier series for the function mod x. This is one part of the solution. Okay, here you can see there are two parts of the solutions are there. One is to find the Fourier series. To find the Fourier series, another one they are asking to deduce the some series they have given. They are asking to deduce that given series. Now we have obtained the Fourier series. Let us go for the second part of the. This is one part, and here we have obtained. Let us go for the second part. To deduce the required series. To deduce the required series, let us put x equals to 0. Let us put x equals to 0 in this series. What we are getting here? That we have f of x, given f of x equals to mod x. If we substitute x equals to 0. Here we are getting f of 0 is equals to 0. Here we are getting f of 0 is equals to 0. That is 0 is equals to pi by 2 minus 2 by pi summation n equals to 1 to infinity 1 by n square 1 minus of minus 1 raised to n cos n into 0. That is equals to, now what I am doing is just transferring this pi by 2 to the LHS. This becomes minus pi by 2. Right? Here I am just transferring pi by 2 to the LHS. This becomes minus pi by 2. Here we are left with minus 2 by pi summation n is equals to 1 to infinity 1 upon n square into bracket 1 minus of minus 1 raised to n. Now here cos n into 0 is cos 0. Cos 0 is 1. Because cos 0 is equals to 1. Cos n into 0 is cos 0. Cos 0 is equals to 1. Therefore, here we are left with minus pi by 2. That is equals to minus 2 by pi. Summation n is equals to 1 to infinity 1 by n square into bracket 1 minus of minus 1 raised to n. This is here we have obtained. Still now it is not the required answer. Now what I am doing is I just want to substitute the value for this bracket. I just want to substitute value for this bracket. Just look here. Now I am just finding the value of 1 minus a minus 1 raised to n. Okay, what value we are going to get here? Okay. Here we are getting 1 minus of minus 1 raised to n value 0, 0 if n is even. If n is even, how it is? Even numbers are nothing but 2, 4, 6, 8, so on. These are the even numbers. If you substitute minus 1 raised to 2, minus 1 raised to 4, minus 1 raised to 6 and so on, what you are going to get? This is plus 1, plus 1, plus 1, plus 1 and so on. Okay, here we have 1 minus of minus 1 raised to n. What you are getting? Means if you substitute here, this is 1 minus 1 which is equals to 0. Because here this bracket value are going to get plus 1. That is 1 plus 1 is 1 minus of plus 1. That is 1 minus 1 which is equals to 0. If you put 4, again 0. If you put 6, again 0. Nothing but if you substitute n equals to even numbers, then we are going to get the value of this term is 0. Next, if we substitute odd numbers, that is minus 1 raised to 1, minus 1 raised to 3, minus 1 raised to 5 and so on. What value are we going to get? This is minus 1, minus 1, minus 1 and so on. Now you have the term 1 minus of minus 1. If it is 1, then it is 1 minus into minus plus 1 which is equals to. If minus 1 raised to 3 is there, then you are going to get 1 minus of minus 1 number. In this case also you are going to get 2. Similarly, 1 minus of minus 1 raised to 5. That is also 1 minus of minus 1 which is equals to 2. That means if n is odd, we are going to get the value as 2. If n is even, the value is equals to 0. Here the value of 1 minus of minus 1 raised to n value is 2 if n is odd. If n is odd. Substituting value here, therefore minus pi by 2, that is equals to minus 2 by 5 summation n is equals to 1 to infinity 1 by n square into 2. From this one, I have substituted the value is equals to 2. Minus pi by 2, that is equal to, again 2 is a constant, taking outside the summation, this is minus 4 by 5, summation n is equals to, okay, here we have considered the odd values, therefore 1, 3, 5 and so on. N is equals to 1, 3, 5, so on up to infinity, means odd values. Here we are considering n is equals to 1, 3, 5 and so on up to infinity 1 by n square. Now you can see it is minus 4 by pi into is there. Transfer this minus 4 by pi to LHS pi by 2. This because minus pi by 4. Minus pi by 4 यहाँ पे मल्टीप्लिकेशन है, यहाँ पे सम फॉर्म में था और डिफरेंस फॉर्म में था. We are left in the RHS summation n equals to 1, 3, 5 to infinity 1 by n square. Now here minus into minus becomes plus pi into pi square upon 2 into 4 it is 8 which is equals to. Now substituting for n the odd numbers, that is 1, 3, 5 and so on. Here we have 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square plus 4. Right? This is nothing but our required series. This is what they are asking.